Welcome back to my channel. Today we are going to continue with Intermediate Python. Build a histogram 1. So we are starting with a list called Life Experience, and MatPlotLib is imported as PLT. And our goal is to see how life expectancy in different countries is distributed, and we're going to use a histogram to do that. So we should do plt.hist, which creates the histogram. I'm assuming that we're supposed to do life expectancy in here, and then we just do plt.show, and now we run. Alright, and it defaults to 10 bins, which I assume are the bars. So I don't know what a histogram is, but this looks like a bar chart to me. Okay, and then you see a dramatic change here. Okay, let's submit and see what happens. Great job! Build a histogram 2. Bins. Okay, so we're gonna use only 5 bins in this one. And line 13, plot.clf. Plot.clf cleans up the plot so you can start over. Oh, it's also line 6. So that's why we need the CLF here on line 6, because we're gonna go to line 9 to create a new histogram. Alright, so to build a histogram, we're gonna do plot.hist, and we're gonna pass in the life expectancy, and that builds that histogram. Oh, and then we need with 5 bins, so I'm gonna try if we just put the number there, and we'll see what happens. And then I'm gonna do the same here. Hist, life expectancy, and we're gonna do 20 bins. Let's run this. Alright, this does look like maybe double what we had. Oh, so you say previous plot, and this is 5. Okay, so let's submit. Nice. You can use the buttons to browse through the different plots you've created. Alright, continue. Build a histogram 3. Compare. Alright, we're building a histogram of life expectancy with 15 bins. So this will be similar to what we did in the last one. Life expectancy, and we're at 15 bins. Then they showed and cleared. And now we're gonna do plot.hist for life expectancy 1950, and that's also 15 bins. Run. Now, there's nothing in here comparing the data. I guess that's for us to do. Yep, it changed a lot. The spike is on this end, where over here it's kind of more near the beginning, and the other end is a little bit bigger than this end over here. This is more steady at the beginning. Alright, submit. Great. Toggle between the created plots. Do you notice anything interesting? Alright, now we have another multiple choice. Choose the right plot. You're a professor teaching data science with Python, and you want to visually assess if the grades on your exam follow a particular distribution. What plot do you use? Well, you say to me distribution, and I say scatter plot. But since we've been dealing with histograms, I'm gonna guess it's that. Excellent choice. Yeah, I don't know enough about charts and all that to know why. You're a professor in data analytics with Python, and you want to visually assess if longer answers on exam questions lead to higher scores, higher grades. Which plot do you use? I would have to really do a lot of work to find the answer for sure. So I'm gonna guess it's a histogram since that's what we've been working with. No. There's two variables involved, time to take the exam and the corresponding grades. A histogram is not a suitable option in this case. So is this a scatter plot? Good choice. Labels. So from what I can tell, they've created a plot, they've changed the scale to logarithmic, they've created the strings for the x-axis label, the y-axis label, and the title. Then we use these three functions to, with the strings that they created, to actually add the labels and title. So we do x label and pass in x lab, and then we do y label and pass in y lab, and then we do title with the parentheses as a function, and we pass in title, the variable. And now we display it, which is just plt.show with the parentheses to show it's a function. Nope. Okay, what am I doing here? Put plot. It comes from this package. It says these functions are available in this package that we imported, that it imported off the screen. And then we do the same with title. Alright, now we run. And there's a scatter plot. Oh, title? Oh, they have the X label and the Y label. Yeah, I just swapped those. Okay, those are what the labels are. And then the title at the top. Submitting. This looks much better already. Continue. Ticks. Okay, so they've put in their scale, which is logarithmic, their scale, which is logarithmic, the X and Y axis labels, and the title. They've also created the scatter plot, which for some reason they never had us do. For scatter plot, you pass in two variables. So one would be the X coordinate and one would be the Y coordinate, I guess. Which I'm guessing GDP cap is the X coordinate and life expectancy is the Y coordinate. And that's how you get a dot. Okay, then lines 11 and 12, they made their tick values lists. So one thing I want to point out, if you're making a histogram and let's say you're given this list or it's something that's in a database somewhere, it may change at different times, and you want to use a histogram, you can just set the number of bins to the size of this, list. One list or the other. Adapt the ticks on the x-axis. So we're gonna do, because I forgot last time, plt dot, and then x ticks, which they give us in the exercise information. And we're gonna pass in, so you have to pass in the two things. So it says, in the instructions, it has the tick value listed first. So I'm gonna do that. And then the tick label is second. And then I'm guessing we show it. plt.show. Run. And here's our scatter plot, and they changed these numbers to 1K, 10K, and 100K. So we used plt.xticks. So I'm guessing there's also a function plt.yticks if you wanted different numbers. Great, your plot is shaping up nicely. I'm guessing those multiple choice questions were supposed to be where we said, oh, okay, so we've been using a histogram, but what we actually want to use for this is a scatter plot. Sizes. So what I'm understanding from this is that when you use a specific type of plot, the plt.scatter, plt.hist, and whatever we were doing in the previous video, there's a lot of different options of how to customize each one for exactly what we need. So what we're gonna do is change each dot on the scatter plot to be bigger for higher populations and smaller for lower populations. And what it says at the top is we import numpy as np. Hang on. Okay. I don't need to type that whole thing out. I know I typed it and deleted it, but screw it. Okay, so we need to change pop into a numpy array called nppop. That equals np dot, is it array? It's been a while, of pop. They want us to double np pop, which should mean that we double each value inside here. And we know we can just do some action. I don't remember how to do it though. Oh, okay, don't put it in brackets. It says it on this dot in the instructions. You just do np pop, times 2, and then they did everything else. So we're gonna run this. Nope. Oh, okay. The import I is a lowercase I. So I would have had to have done 2 things. Oh, look at that, they got it. So these two have a really big population. Oh, it's a third variable. Okay, I see what they're saying. So you have really small populations with fairly low life expectancy. Up here you have small populations with high life expectancy. This has medium-sized GDP. No, this has medium-sized population, but high life expectancy and pretty good GDP compared to all the others. It's one of the highest. Alright, submit. Nope. Did you correctly double nppop by setting its value equal to nppop times 2? np? Yeah, I did. Here, use the next hint. nppop equals np.array of pop. Yeah, just show the answer. Oh, okay, they added in their comment. So that is a requirement. So do not take out their comment. Bellissimo. Does Italian do a L sound for double L? Because Spanish doesn't. Can you already tell which bubbles correspond to which countries? I cannot not know. How would I know what countries have high population? Colors. Okay, so they've matched each country to a continent and assigned each continent a color. And according to this, we haven't learned about dictionaries, so I'll just say a dictionary, you use a curly brace instead of a bracket, and it's similar to a list, you just give it a label along with the value, instead of just giving it a value. Okay, so they're saying that this first dot in the plt.scatter, so that's line 2, we're gonna add in this comma C equals COL. So COL is a variable they created behind the scenes, which is, I assume, this dictionary. And then C is the placeholder for the scatter plot so that it has a default value. But if you need to set a value, You just have to tell it which one you're using, like they have here. Y equals, and X equals, and S equals. Because if you don't tell it which variable you're using, then it won't know. Alright, they're saying there's also one called alpha, and we're setting that equal to 0.8. Alpha can be a number from 0 to 1, where 0 is totally transparent and 1 is not at all transparent. Okay, so red is Asia, green is Europe, blue is Africa, yellow is the Americas, black is Oceania, which is Australia and New Zealand. So I think there's one. Is there another one there? The colors kind of help me differentiate where there's even dots. Like I wouldn't have known that there were so many dots inside this big red one here. Submit. Oh, so the reason that we wanted the alpha to be 0.8 is so that we can kind of see the difference between dots like these red ones, I guess. Nice. This is looking more and more like Hans Rosling's plot. No idea who that is or what that means. Additional customizations. Line 12 and 13. They've added text for India and China to add labels to those dots. And then we are meant to do plt.grid, and that is true. So that will show the grid lines and run. Oh, okay, grid lines, so you can see exactly where a certain number is. Beautiful. A visualization only makes sense if you can interpret it properly. Let's do that in the next exercise. Interpretation. If you have a look at your colorful plot, it's clear that people live longer in countries with a higher GDP per capita. No high-income countries have really short life expectancy, and no low-income countries have a very long life expectancy. I mean, there are some outliers. Still, there is a huge difference in life expectancy between countries on the same income level. Most people live in middle-income countries where the difference in lifespan is huge between countries, depending on how income is distributed and how it is used. What can you say about the plot? This last option is definitely false because China has the higher GDP and the higher life expectancy. So that's obviously false. And I'm pretty sure that the middle one is false because what would a negative correlation be? A negative correlation would be the higher one is, the lower the other is. But for this, the higher one is, the higher the other is. You have more similar to that. So only the top one could be true. The countries in blue corresponding to Africa have both low life expectancy and low GDP per capita. Some of them there are outliers and some of them are not doing as bad, and hopefully they continue to do well. Correct. Up to the next chapter, on to dictionaries. Okay, so the next one should be once we watch a video. So I'm going to stop this video here. Thank you for watching, and let me know if you have any comments about this, how I could do better. Have fun on your own projects.